Hello, we are team.csv from and today we will be presenting on our product, a low-cost multi-power point tracking solar charge controller. The world is facing an unprecedented energy crisis. In 2019, fossil fuels such as oil, coal and gas accounted for more than 80% of energy consumed globally, causing greenhouse gas emissions to increase rapidly at a time when the climate cannot afford it. From the list of renewable energy sources, solar energy has emerged as the most popular for small-scale off-grid systems due to its versatility and scalability.
Closer to home, the Singapore government has announced plans to boost Singapore's solar output to 2 gigawatts by 2030, 6 times the capacity as of 2020. Hence, improving the efficiency of solar energy will be crucial in keeping costs down and achieving this ambitious goal. Although Singapore typically enjoys a sunny tropical climate, high humidity leads to high cloud cover and hence fluctuations between sporadic full sunlight and partial shade. To understand how this affects efficiency, we first consider the IV curve of a typical solar panel. Since current does not vary linearly with voltage, there exists a voltage and corresponding current setting at which power is the maximum. This is known as the maximum power point, or MPP for short. Under standard test conditions, this point is given by manufacturer's specification. However, when conditions constantly change, as per Singapore's climate, this MPP shifts. Hence, operating at the manual specified MPP does not yield maximum power. Introducing the Maximum Power Point Tracking Solar Charge Controller, or MPPT Solar Charge Controller for short. An MPPT solar charge controller hence tracks this MPP using a sophisticated algorithm and constantly ensures that the voltage across the panel is at the voltage which yields the maximum power, and in doing so extracts maximum power from the solar panel, thereby increasing efficiency. Conventional MPPT charge controllers are typically extremely expensive and lack experimental features such as Wi-Fi capability and data logging for monitoring. Our product hence aims to bridge this gap. As such, our target users are primarily at this stage of production, hobbyists and households who may wish to experiment with solar energy for lighting and other undemanding applications. Hence, cost will most likely be the largest concern for these end users, followed by convenience features such as Wi-Fi control and logging, especially since smart home and voice control is becoming a thing. Our product costs about 2/3 the cost of the nearest competitor and packs in more features. Firstly, it's Wi-Fi enabled and has a microSD card slot for data logging. As with most charge controllers, an LCD GUI enables changing core parameters such as cutoff and charging voltages, which can also be turned off via a switch when not in use to reduce power consumption. Our product also features a real-time clock, which means one can schedule timers for the output. 3 indicator LEDs provide users with basic information such as status of the RTC and SD as well as battery presence. As for data logging and remote monitoring options, we have experimented with Blink and ThinkSpeak, 2 open source Internet of Things or IoT platforms which have allowed us to monitor and log data from sensors to the web, providing easy access to data visualization and remote monitoring of the system. As the ESP8266 board that is used in our prototype is supported across various IoT platforms, users with limited experience in coding should be able to use our product with their IoT platform of choice. As this project is also open source, files and code are linked in the GitHub repo. As of now, we are unable to ascertain our product's efficiency and compare it to other products as we lack basis for comparison. However, initial trials and data show that the basic functionality is present. We hope to further refine the MPPT algorithm of our product and conduct further testing so that our product may be a serious DIY alternative to proprietary charge controllers for low cost or experimental applications.